Software is a program or set of programs containing instructions that provide desired functionality. And engineering is the process of designing and building something that serves a particular purpose and finds a cost-effective solution to problems. In this video, Trust will explain the basic concepts covering software engineering. Software engineering is the process of designing, developing, testing, and maintaining software. It is a systematic and disciplined approach to software development that aims to create high-quality, reliable, and maintainable software. Software engineering includes a variety of techniques, tools, and methodologies, including requirements analysis, design, testing, and maintenance. The COCOMO, constructive cost model, is a widely used software cost estimation model in software engineering. It was introduced by Barry Boehm in 1981 and has since undergone several revisions. The model is designed to estimate the effort, time, and cost required for developing a software project. COCOMO is particularly useful in the early stages of a project when detailed information about the system is not yet available. There are three versions of COCOMO: Basic COCOMO, Intermediate COCOMO, and Detailed COCOMO. Basic COCOMO. This is the simplest version of the COCOMO model. It estimates effort as a function of the size of the software project, measured in lines of code. Intermediate COCOMO. This version extends Basic COCOMO by introducing additional cost drivers to account for various factors that influence software development effort. Detailed COCOMO. This is the most comprehensive version of the COCOMO model. It provides a more detailed and accurate estimation by considering various subfactors within the cost drivers. Testing is a crucial phase in software engineering that ensures the quality, reliability, and functionality of a software product. There are several types of testing, each serving a specific purpose in the software development life cycle. Here are some common types of testing in software engineering. Unit testing. This type of testing focuses on individual units or components of a software application. The goal is to validate that each unit of the software performs as designed. Unit tests are typically automated and are executed during the development phase. Integration testing. Integration testing verifies the interactions between different components or systems in the software. The objective is to identify and address issues related to the integration of these components. It can be conducted at different levels, such as module integration, system integration, and user acceptance testing. System testing. System testing evaluates the entire software system as a whole. It ensures that all components work together correctly to deliver the intended functionality. It includes functional and non-functional testing to assess the system's compliance with specified requirements. Alpha testing and beta testing are two important phases in the software testing process, occurring at different stages of a software product's development life cycle. Alpha testing is the initial phase of testing, and it is conducted by the internal development team within a controlled environment. The testers are usually members of the development team or a specialized testing team. The primary focus of alpha testing is to identify and fix issues with the software's functionality, usability, and overall behavior before it is released to a larger audience. Beta testing is conducted after alpha testing and involves a limited release of the software to a select group of external users or customers. The testing environment is real-world and diverse, reflecting the conditions under which the software will ultimately be used. Beta testers are external users who may not be part of the development team. They provide valuable feedback from an end-user perspective. Verification and validation is the process of investigating whether a software system satisfies specifications and standards and fulfills the required purpose. Barry Boehm described verification and validation as the following. Verification. Verification is the process of checking that software achieves its goal without any bugs. It is the process to ensure whether the product that is developed is right or not. It verifies whether the developed product fulfills the requirements that we have. Verification is simply known as static testing. Validation. Validation is the process of checking whether the software product is up to the mark, or in other words, product has high-level requirements. It is the process of checking the validation of the product, i.e. it checks what we are developing is the right product. It is a validation of actual and expected products. Validation is simply known as dynamic testing. Here are some of the activities that are involved in validation. Black box testing. White box testing. The waterfall model. The classical waterfall model is the basic software development life cycle model. It is very simple but idealistic. Earlier this model was very popular, but nowadays it is not used. Why do we use the waterfall model? The waterfall model is a software development model used in the context of large, complex projects, typically in the field of information technology. It is characterized by a structured, sequential approach to project management and software development. Sequential approach. The waterfall model involves a sequential approach to software development, where each phase of the project is completed before moving on to the next one. Document-driven. The waterfall model relies heavily on documentation to ensure that the project is well defined and the project team is working towards a clear set of goals. Feasibility study. The main goal of this phase is to determine whether it would be financially and technically feasible to develop the software. The feasibility study involves understanding the problem and then determining the various possible strategies to solve the problem. These different identified solutions are analyzed based on their benefits and drawbacks. The best solution is chosen and all the other phases are carried out as per the solution strategy. The prototype model. The prototyping model is one of the most popularly used software development lifecycle models, SDLC models. This model is used when the customers do not know the exact project requirements beforehand. In this model, a prototype of the end product is first developed, tested, and refined as per customer feedback repeatedly till a final acceptable prototype is achieved, which forms the basis for developing the final product. Build a prototype. This step helps in building an actual prototype from the knowledge gained from prototype design. Prototyping can facilitate communication and collaboration among team members and stakeholders, improving overall project efficiency and effectiveness. Prototyping can help bridge the gap between technical and non-technical stakeholders by providing a tangible representation of the product. Agile development. Agile development is an iterative and flexible approach to software development that emphasizes collaboration, customer feedback, and the ability to adapt to changing requirements. It contrasts with traditional, linear development methods by promoting a more dynamic and responsive process. Modularization in software engineering refers to the practice of breaking down a software system into smaller, self-contained modules or components. Each module represents a distinct piece of functionality, and the system as a whole is built by combining these modules. This approach offers several benefits and is fundamental to the principles of modularity, encapsulation, and abstraction. Forward engineering. Forward engineering is the traditional process of designing and creating a software system from scratch. It involves starting with requirements analysis, progressing through system design and implementation, and ultimately producing a working software product. Reverse engineering. Reverse engineering, on the other hand, involves analyzing an existing software system to understand its design, functionality, and structure. Reverse engineering is often a nonlinear and exploratory process, involving activities such as decompiling, disassembling, and analyzing the binary code, or examining documentation and source code if available. Forward engineering is the conventional process of creating software from scratch, following a planned sequence of steps. Reverse engineering, on the other hand, involves understanding and analyzing existing software, often to gain insights into its functionality, structure, or to make modifications without access to the original source code. Software project management, SPM, is a proper way of planning and leading software projects. It is a part of project management in which software projects are planned, implemented, monitored, and controlled. Software measurement. A measurement is a manifestation of the size, quantity, amount, or dimension of a particular attribute of a product or process. Software measurement is a titrate impute of a characteristic of a software product or the software process. It is an authority within software engineering. The software measurement process is defined and governed by ISO standard. A metric is a measurement of the level at which any impute belongs to a system, product, or process. Software metrics will be useful only if they are characterized effectively and validated so that their worth is proven. The software development cycle. The software development cycle, also known as the software development life cycle, SDLC, is a systematic process for planning, creating, testing, deploying, and maintaining software. The SDLC is a framework that guides the development process from the initial concept to the final product. Requirements analysis. Identify and gather detailed requirements from stakeholders to understand the purpose, features, and constraints of the software. Planning. Develop a project plan outlining tasks, timelines, resources, and potential risks. Determine the project scope, budget, and schedule. Design. Create a high-level design specifying the overall architecture and structure of the software. Develop detailed design specifications for each component or module. Implementation, coding. Write code based on the design specifications, translating the requirements into a functional software product. Follow coding standards and best practices. Testing. Conduct various levels of testing to identify and fix defects. Types of testing include unit testing, integration testing, system testing, and user acceptance testing. Deployment. Release the software for use by end users. Ensure a smooth transition from development to production. Maintenance and support. Address issues, bugs, and user feedback. Make updates or enhancements to the software as needed. Thank you for watching this video. Make sure to subscribe and like. Till next time, CyberX Innovation.